Ever wonder why superheroes switch costumes? Flexibility and the element of surprise. Just like our coding superhero, the array list brings flexibility to Java's world. Unlike traditional arrays that are like fixed-size costumes, array lists allow heroes to adapt, grow, and shrink their size dynamically. No more predicting how many villains or elements you'll face. Imagine you're hosting a superhero party. With a traditional array, you must know the exact number of guests before sending out invites. But life isn't that predictable. Enter array lists, the life of the party, where you can add or remove guests anytime without a fuss. Array lists are not just about flexibility, they're about power. They come packed with features that make managing lists a breeze. Need to insert a guest in the middle of the list? Done. Find out if a particular superhero is coming? Just ask. But remember, with great power comes great responsibility. Array lists can consume more memory and might be a tad slower with very large lists. However, for most superhero tasks, their advantages far outweigh these concerns. So next time you're coding, ask yourself, do I need a rigid costume or the flexibility of an array list?
Imagine you're on a treasure hunt, where each clue leads you to the next location. Linked lists work similarly in computer science. They are like a series of connected nodes, where each node contains a value and a pointer to the next clue or node in the list. Unlike an array, which is like a treasure map showing all locations at once, linked lists reveal one location at a time, making them flexible because you can easily add or remove elements without reshuffling the entire map. Now, why use a linked list? Imagine planning a road trip with friends, and you decide the next destination only after reaching the current one. Linked lists are perfect for when you need this kind of flexibility, like dynamically adjusting your route. However, just like deciding on the next spot can take time, linked lists have a drawback. Accessing an element in the middle of the list requires starting from the beginning, making it slower than glancing at a full map, like an array. But here's the cool part. With linked lists, you're not limited to a single treasure hunt. You can have multiple adventures or types of linked lists, like doubly linked lists, where each clue points both ways, forward and backward, allowing you to revisit decisions easily. And then there's the circular linked list, where the treasure hunt loops, and the last clue leads back to the first, making it a never-ending adventure.
Imagine you're on a thrilling adventure in a mystical library, searching for ancient wisdom. You come across a magical book stack that operates on a peculiar but powerful principle. The last book you put on it is the first one you must take off. This, my friends, is the essence of a stack, a fundamental data structure in the world of programming. Stacks are like magical stacks of books, pancakes, or even superhero gadgets in your utility belt, where the last item you added is the first one you retrieve. This last in, first out, or LIFO method isn't just a whimsical rule. It's incredibly useful in organizing data efficiently. Why are stacks so awesome? They help maintain order in the chaos of data, streamline tasks like undoing actions in a text editor, navigating pages in a web browser, and even solving complex puzzles in your code. Imagine putting on your superhero cape and effortlessly gliding through tasks with the power of stacks. So whether you're a budding programmer or sharpening your coding skills, understanding stacks is like discovering a secret passage in the library of programming knowledge. It unlocks new strategies, simplifies tasks, and yes, makes you a coding wizard in your adventure through the realm of code.
Welcome to the bustling world of theme park coding land, where the clue is not just a line for the roller coaster, but a superpower in the coding universe. Picture this. A clue is like the line for your favorite ride, where the first person in line is the first to experience the thrill. This first in, first out, or FIFO principle isn't just about fairness, it's a cornerstone of organizing data in computer science. Imagine you're a DJ at the park's grand disco, playing tracks requests. A clue ensures the first song requested is the first played, keeping the dance floor happy and energetic. It's all about waiting your turn and ensuring smooth operations, whether for music, printing documents, or even managing tasks in your computer. Cues bring order to chaos. They're like the wise guardians of a castle, ensuring everyone gets their chance to shine at the right moment. In programming, they help manage resources efficiently, from handling web page requests to queuing up tasks for processors. is the unsung hero making sure everything runs smoothly behind the scenes, like ensuring every thrill seeker gets their turn on the ride without a hitch. So next time you're in line, remember the humble clue. It's not just about waiting. It's about making sure everyone gets to enjoy the ride, both in theme park coding land and in the vast, adventurous world of programming.
Welcome to the city of Cotterville, a bustling metropolis where information is always on the move. In this city, the map data structure is like the ultimate phone book, guiding us to find exactly what we're looking for instantly. Imagine you're a detective in Cotterville, and each clue leads you to the next. With a map, you can jump straight to the answer, no detours needed. Maps store information as key value pairs. Think of it as a treasure chest, where every treasure, value, has a unique key. Need the secret formula? Look up its key, and voila, it's in your hands. This is why maps are so powerful. They make retrieving information incredibly fast and efficient. Why are maps a game changer? They eliminate the need for searching through lists, making data retrieval almost magical. Whether you're tracking the villains of Cotterville or just storing your favorite places, maps keep things organized and accessible. In the programming world, maps light up the path to efficient coding. They help manage data so you can focus on solving bigger mysteries, like saving Cotterville from a code apocalypse. With maps, you're not just coding, you're embarking on an adventure where every piece of data is a clue leading you to victory. So whether you're just starting your coding journey or you're a seasoned code detective, the map data structure is your trusty companion in the quest for clean, efficient, and effective programming.
Welcome to the unique world of Puzzle Island, where every piece is distinct and duplicates simply vanish. Imagine exploring this island with a magical bag, a set. In this bag, if you try to put in two identical puzzle pieces, the bag magically keeps on. This is the essence of a set, a fundamental data structure in the enchanting realm of programming. Sets are like exclusive clubs where each member is unique. No repeats allowed. This makes sets incredibly powerful for tasks where uniqueness is key. Need to sift through a list of magic spells without repetition. A set is your go-to. Organizing a treasure hunt where each clue is one of a kind. Again, sets save the day. Why are sets so marvelous? They simplify our coding adventures by automatically removing duplicates, making data easier to manage and analyze. Plus, they offer super fast ways to check if an item exists, merge collections without overlap, and even find differences between groups of items. Imagine sets as your loyal sidekick in the quest for clean and efficient code. They help keep your treasure chest of data tidy and ensure that every piece of information is as unique as the starry night sky. So, embark on your coding journey with sets by your side. They'll make sure your adventures through code are both thrilling and duplication-free, leading you to discover the treasures of efficient and effective programming.
Welcome to the Enchanted Forest of Code, a mystical place where the trees hold the secrets of efficient data organization. Among these magical beings, the tree data structure stands tall, branching out to store information in a way that mimics the wisdom of nature itself. Imagine each tree as a family tree of data, where each branch represents a choice, leading to more branches or leaves. At the very top is the root, the ancestor of all data points below. This hierarchical structure isn't just for show. It makes finding, adding, and organizing data as natural as the cycle of the seasons. Why are trees so beneficial? They allow us to store information in a sorted manner, making it faster to search, add, or delete data. Like paths through the forest, trees guide us to our data destination using the quickest route, avoiding the tangled underbrush of less organized structures. From binary trees that keep things simple with yes or no decisions, to more complex varieties like ABL trees, which balance themselves to prevent any side from growing too long. Trees are the wise guardians of data, ensuring it's always accessible and efficiently stored. So venture into the enchanted forest of code with the tree data structure as your guide. With each branch and leaf, you'll find your way through the vast, sometimes bewildering world of data, reaching your goals with the grace and wisdom of the natural world.
Imagine embarking on an adventure in the vast galaxy of connections where stars represent cities and the routes between them are pathways of light. In this galaxy, navigating from one star to another is crucial for explorers. This is where the graph data structure shines bright, mapping out connections in a network of endless possibilities. Graphs are like the cosmic maps of the programming universe. They consist of nodes or vertices, which you can think of as islands in an ocean or stations in a metro system. The connections or edges represent the bridges or tunnels linking these nodes. Whether these connections are one-way teleportation beams or bidirectional trade routes, graphs help us understand and navigate complex networks with ease. Why are graphs so out of this world? They empower us to model real-life relationships and networks, from social media friendships and web page links to city roads and beyond. Graphs bring to light the shortest paths, the most influential nodes, and the most efficient ways to traverse vast networks. With graphs, you're not just coding, you're architecting universes of connections. They're the backbone of search algorithms, social networks, and even GPS navigation systems. By mastering graphs, you unlock new dimensions of problem solving where every node is a world and every edge a journey. So suit up for your journey through the galaxy of connections. With the graph data structure as your guide, you're set to explore the cosmos of coding, discovering the most efficient routes and unraveling the mysteries of interconnected data.